exercise 7.8. Next sum number 17. Integral from 0 to pi by 4 2 secant square x plus x cube plus 2. First, let us separate integral for each term. Then we can do integral, then we can apply limits. That is better. 3 terms are there. That means integral from 0 to pi by 4 2 secant square x dx plus integral from 0 to pi by 4 x cube dx, integral from 0 to pi by 4 2 dx. Integral separated for each term. Now two constant keep outside. Integral from 0 to pi by 4 secant square x dx, 0 to pi by 4 x cube dx, 0 to pi by 2 2 dx. 2 I will keep outside. Then 1 into dx. 2 into 1, 2. 2 constant, keep it. Secant square x. We have direct integral for secant square x. Integral of secant square x is tan x. 0 to pi by 4. Integral of secant square x is tan x. Plus integral of x cube. X power 4 by 4. X power an integral. X power n plus 1 by n plus 1. Basic formula. 0 to pi by 4 the limits. 2 constant. Integral of 1 dx. X. 0 to pi by integrals. Now let us apply the limits. Nothing is there. Integral completed. For each term we have to apply the limits. 2 into tan pi by 2 upper limit minus tan 0. Upper limit pi by 4. In the place of x pi by 4 whole to the power of 4. By 4 is there again. In the place of x pi by 4. Upper limit completed minus lower limit 0. Anyway it is going to become 0. 2 into upper limit pi by 2 minus lower limit 0. It is applied or not up. If you write or not write, no problem. Anyway 0. Then 2 into tan pi by 2. Tan 90. Tan 90 value. We can write actually pi by 4. Pi by 4. It is pi by 4. By mistake I wrote pi by 2. Now we have to apply upper limit pi by 4. And everywhere I applied pi, here also pi by 4. The limits are 0 to pi by 4. So pi by 4. It is pi by 4. 2 into upper limit is pi by 4. Everywhere I presented pi by 4. Tan pi by 4 value 1. Tan 45 1. Tan 0 is 0. No need to write. Pi by 4 whole to the power of 4 means pi to the power of 4 by 4 to the power of 4. This 4 goes to here only into 4. Pi to the power of 4 by 4 to the power of 4. This 4 goes to here only into 4. Plus 2 into pi by 4. 0 can skip it. Here 0 can skip it. Last step. 2 into 1 2 plus pi by 4 by 4 power 4 into 4 power nothing means 1. Bases equal. Add the powers. 4 plus 1. 4 to the power of 5. 4 to the power of 4 into 4 to the power of 1. 4 to the power of 5. 2 we can cancel here 2 times. Plus pi by 2. That's enough. That is the maximum simplification we can do. Otherwise we can do one step. Pi by 4 I will write first. Pi by 4 by 4 to the power of 5. 4 to the power of 5 means 4 into 4 into 4 5 times. That gives 1024 plus pi by 2. We are writing in the order. Plus pi by 4 1024 pi by 2 plus pi by 4 pi to the power of 4 by 4 power 5. I wrote first 4 power 5 value is 1024 plus pi by 2 plus 2. It is a final integral. So here only we should know integral of secant square x formula. Remaining all basic formulas. This is only trigonometry. Next, ideal integral from 0 to pi sin square x by 2 minus cos square x by 2. 0 to pi by 2 sin square x by 2 minus cos square x by 2. We know cos 2 theta formula, one side, right? Cos 2 theta is equal to cos square theta minus sin square theta. Then cos theta is equal to cos square theta by 2 minus sin square theta by 2. 2 theta means theta. Then when the angle became half here, LHS, by RHS also angle will become half. So cos theta formula, cos square theta by 2 minus sin square theta by 2. If you take minus common, that means minus of, if you write sin square theta by 2 minus cos square theta by 2. I take a minus common. Minus into sin square theta by 2 minus sin square theta by 2 minus of minus plus cos square theta by 2. So we are having sin square theta by 2 minus cos square theta by 2. This is cos theta. If you shift minus this side, minus cos theta is equal to sin square theta by 2 minus cos square theta by 2. That means both sides multiply with minus. Minus into cos theta minus of minus plus. Now we are having, this is our situation. Sin square theta by x by 2 minus cos square x by 2. In the place of x, theta. That is nothing but 0 to pi. I can write instead of this minus cos theta. So up to now I did not do anything. Trigonometric formula simplification I applied here. In the place of sin square x by 2 minus cos square x by 2, we can write minus cos x. In the place of theta x. Minus keep outside. Integral from 0 to pi cos x dx. Minus we kept outside. Now integral of cos x is sin x. Integral of cos x is sin x. Directly integral formula. Integral of cos x is sin x minus is outside. Now apply the limits. Sin pi minus sin 0. We know trigonometric values. Sin pi is 0. Sin 0 also 0. Then total it is 0. It is the final. So here this is a basic formula we should know. From the cos 2 theta formula, from the cos theta formula. Just we take a minus common. Both sides multiply with minus. Then sin square theta by sin square x by 2 minus cos square x by 2 is minus cos x. So these basic formulas are required. Next, integral from 0 to 2, integral from 0 to 2, 6x plus 3 by x square plus 4. This is 90. It is simple. In the numerator, I will take 3 common and I will write outside 0 to 2. If I take 3 common here, 2x. 3 taken common means 1 by x square plus 4. End it out, multiply with 3, you will get that. 3 into 2x, 6x. 3 into 1, 3. We taken 3 common and kept outside. Now the denominator, I will separate for both the terms of numerator. 0 to 2. 2x by x square plus 4 plus 1 by x square plus 4 dx. Next we can separate integral and 3 also for each term. That means 3 into 0 to 2, 2x by x square plus 4 dx. 3 into 0 to 2, 1 by x square plus 4 dx. Okay, we are separating 3 into integral from 0 to 2 for both the terms. Now if you observe, if you consider it is f of x, this will be f dash of x. Why? Because x square plus 4 derivative. X square derivative 2x, 4 derivative 0. So x square plus 4 derivative is 2x. So if it is f of x, this numerator becomes f dash of x. Now this 4 I can write here 2 square. At a time I can apply here and there also formulas. 3 keep constant. It is f dash of x, it is f of x. We know the formula. Integral of f dash of x by, most frequent we are using this formula. Dx is equal to log f of x. Very frequently we use this formula. Next, this formula also write integral of 1 by x square plus a square dx is equal to 1 by a into tan inverse x by a. these two formulas. For first integral, first formula. For second integral, second formula. 3 into log f of x. Log f of x means here x square plus 4. But the thing is limits. 0 to 2 we have to 3 into here also. 1 by a means 1 by 2. In the place of a 2. 1 by a into tan inverse x by a means x by 2. Apply the limits 0 to 2. Then 3 into log upper limit 2. 2 square means 4. 4 plus 4 8. Log 8 minus lower limit 0. 0 plus 4 4. Log 4. Okay. First upper limit 2. 2 square means 4. 4 plus 4 8 minus lower limit 0. 0 square plus 4 4. 3 into upper limit minus lower limit. Same here also. 3 into 1 3. 3 by 2. Upper limit 2. That means tan inverse 2 by 2 minus tan inverse 0 by 2 means 0. Lower limit 0. 0 by anything is 0. Tan inverse 0 we know. Otherwise one step ahead. Tan inverse 0. 3 of log h. Log a minus log b. Log a by b. We can write here log a by b. Plus 3 by 2 into tan inverse 2 by 2. 1. Tan inverse 0 is 0. We know that tan inverse 0 is 0. Then 3 into 2 in 1. 4 in 8 we can cancel 2 times. Then it is log 2 plus 3 by 2. Tan inverse 1 value we know. Pi by 4. 0 leave it. Tan inverse 1 is pi by 4. That means 3 log 2 plus 3 into pi. 3 pi by 8. If we can keep 3 log 2 we can leave it. Otherwise 3 coefficient we can make as power. That means log 2 cube plus 3 pi by 8. We can leave it. Otherwise we can do one more step simplification. Log 2 cube is nothing but log 8. 3 pi by 8. Actually their textbook they left here itself. 3 log 2 plus 3 pi by 8. But we are doing whenever coefficient is there we can make as power. Then log 8. Log 8 plus 3 pi by 8. Otherwise 3 log 2 plus 3 pi by 8. Both are same. So these two formulas are needed here. First formula, second formula. Next, 20th one. Integral from 0 to 1. 0 to 1. X into e power x plus sin pi x by 4. We can separate integral for both the terms. First of all, 0 to 1 x into e power x dx plus 0 to 1 sin pi x by 4 into dx. Actually the pi x by 4 is angle total. Sin pi x by 4. Here these are the two terms. We can take it as the first term, it is as second term. According to Eilert rule, algebra first, exponential next. How to identify? Because these are two independent terms. We cannot make as a single term because x and exponential term, algebraic term and exponential term, both are independent terms. So definitely we must follow integral by parts. First, before applying the by parts, we must identify the order correct or not. We have to identify. According to the word Eilert, we have to identify it is algebra x, e is exponential. So they are in the correct order. Then let us start apply the by parts. First function into by parts process already we done one exercise. First function into integral of second function minus whole integral of derivative of first function. Derivative of first function, integral of second function. Whole dx. Once again I will repeat the by parts process. First function into integral of second function minus whole integral of derivative of first function into integral of second function. Integral of second function. Plus, this is simple. Integral of sin x. Integral of sin x is minus cos x. Minus cos x. In the place of x, pi x by 4. By derivative of pi x by 4. Pi by 4. Only x means we need not. But in the place of x here, pi x by 4. Pi x by 4 derivative is pi by 4. Limits are 0 to 1. Integral of sin is minus cos. Here, x into integral of e power x minus derivative of x is 1, integral of e power x into dx. Limits are there for the total integral 0 to 1. Here plus or minus we can write minus cos pi x by 4. Pi by 4 becomes reciprocal 4 by pi. Limits we can apply for only this term because 4 by pi is a constant. No effect of the limits. Pi by 4 when made reciprocal becomes 4 by pi. Now x into e power x. Integral of e power x, 1 into e power x, integral of e power x is just e power x. Limits are 0 to minus 4 by pi cos pi x by 4. We can apply limits at a time for first and second parts. First here, upper limit 1 into e power 1. Minus e power upper limit completed minus lower limit 0 into anything 0 minus e power 0. Here we have to be careful. Here 0 into whatever 0, but here e power 0 is not 0. E power 0 going to become 1. Why? Because anything power 0 is 1. Minus 4 by pi. Again here also upper limit first 1 cos pi into 1 pi cos pi by 4 minus lower limit cos pi into 0 by 4. Upper limit minus lower limit. 1 into e power 1 minus e power 1 minus 1 0. This one it is also 1 minus 0, skip it, minus e power 0 means minus 4 by pi cos pi by 4 means cos 45 value 1 by root minus pi into 0 by anything is 0. Cos 0 value is 1. Now, two more steps. That is equal to 1 minus 1 0 can skip it. Minus of minus 1 plus 1. 1 minus 1 0 skip it. Minus of minus 1 plus 1. That is equal to 1 minus 4 by pi 1 by root 2 minus 1. Take LCM here. Root 2 LCM. 1 minus root 2. Root 2 LCM 1 minus root 2 into root 2. That means 1 minus 4 by pi 1 minus root 2 by root 2. 1 minus root 2 by root 2 we can write as root 2 minus 1. We can take minus common or we can leave it. 4 into 1 minus root 2. We can leave there itself. 1 minus 4 by pi minus. Otherwise, one thing we can do. This 4 by pi we can split for both the terms. 1 minus 4 into 1 4 by pi into root 2 pi root minus 4 by pi minus of minus plus 4 by pi root 2 cancel one time. That's all. 1 minus 4 pi by root 2 plus 4 by pi. Otherwise, here 4 we can write 2 into 2, 1 root 2 we can cancel. According to your textbook answer, we can write this 1 plus 4 by pi minus 4 I am writing 2 into 2 by pi root. Then they done here 1 plus 4 by pi minus 1 root 2 into we can cancel root 2 times. That means 2 root 2 by pi. This is your textbook answer given. 1 plus 4 by pi minus 2 root 2 by pi. We can leave even here itself, no problem. It is a final simplification. Just we are expanding the terms. Anyway, place is there. Minus 4 by pi into 1. 4 by root 2 as it is. Minus into minus plus 4 root 2 by pi root 2. Root 2 cancel 4 by pi. Again, what I done here? First one, then positive term 4 by pi. Minus 4 by pi into root 2. The 4 I wrote as 2 into 2. root 2 into we can cancel root 2 times. Why? Because 2 is nothing but root 2 into root 2. So this 2 we can this root 2 we can cancel into root 2 times. Then 2 into root 2 by pi. This is the final answer of the 1ds.